Hi everyone, it's me, Carolyn, and we are back at probability. We are working in chapter 5. This video will cover or talk about section 5.3 of our textbook, and we're going to be talking a little bit about independence and dependence and how that affects what we do. So I will go ahead and share my screen. And we see here, first of all, if we have two events, we get rid of that fun. If we have two events, column E and F, just two events, E and F are said to be independent if what happens in one event does not affect what happens in another event. Otherwise, we said that they're dependent. A lot of times this is not for events that are related to the same sample space. It's more about doing something more than once. That's probably the easiest place where we will see them. And if we do have that they are independent, then we can take the probability of E and F happening to be just multiplying those two together. So some examples that we're going to see here are going to be different than an and statement that we saw before. So for example, if we flipped a coin twice, or they flipped the coin and then had a roll of our die, the probability of getting a head and getting a 3, we're looking for that head 3. So it's a little bit different in those situations. And also those are not independent of each other because they do relate to each other. So we have to be a little bit more careful. Here we're going to be seeing more about thinking what happens when we go from one step to the next step. So for example, if we flip a coin 3 times, what happens on that second flip and that third flip is not going to be affected by what happens in the previous flips. So those are going to be independent of each other. So to get the probability of getting 3 heads, we would say, what's the probability of getting a head on that first time? Well, that's 1/2. Probability we get a head on the second one is also 1/2 because it's not going to change. And getting the probability of that third head, is also 1/2. And multiplying those across is 1 out of 8. We also saw flipping a coin 3 times at the end of our previous sections video where I drew the tree. And if you think about getting 3 heads, that was our heads, heads, heads. So it is 1 out of those 8 different possibilities. So this is just another way to get at that same result. But again, if we wanted to extend that to going 12 times, we aren't going to want to create the actual sample space. We aren't going to want to draw the tree that shows us the 12 flips. So that's where this idea comes in handy. We can extend this, because to get a head, all heads, we had to get a head, then a head, then a head, then a head. And again, these are independent from one another because what happens on the first flip does not affect the second flip. So we can do that 1/2 times 1/2 times 1/2. And we're going to do this 12 times. I'm just going to put a little dot, dot, dot in here. But it is 12 times, so that's 1/2 to the 12th power. Okay. Now, to calculate at least one tail, that means we have a tail, 1 tail, 2 tails, 3 tails, and so on. So this is where we start thinking about that complement idea that we saw in the last video as well. Because the opposite of getting at least one tail is getting no tails. And getting no tails is all heads. So we can think about this as being 1 minus the probability of no tails, which is easier for us to calculate. or 1 minus that 1/2 to the 12th. I'm going to get these decimals for you just because I want to make sure you can calculate this value. So looking at my calculator here, I'm going to first of all take that 1/2. You can do this in terms of fractions or in terms of decimals. I will do it in fraction form first. So I am actually going to put the parentheses around it. So my parenthesis, my 1/2, I use that ABC key. Some of you who have a more advanced or a newer calculator than what I have here, you would have that ABC, and it's actually going to have you do the 1 over the 2. You will have to possibly use your arrow keys to enter the 2 to get that 1/2. And now I'm going to end my parentheses. So there's my 1/2, and we want to raise it to the 12th. That's this caret key here to the 12th power. At first, it's going to give me, or it did not give me, it gave it to me in decimal form to begin with, 0.000244, and I'm just going to go there. It does give me more digits. I don't know if this one would actually give it to me in decimal form. So in other words, that 2 to the 12th is a very large number, so it does not like to write that in fraction form. And now what we could do is do 1 minus that value. And I'm going to just actually enter that answer from before, or do minus that 0.99975. And if I were rounding, be 6. So depending on how many digits we want to use. All right, let's do a slightly different question here. Again, we'll go back to our deck of cards. And I'm going to draw a deck of cards with replacement. And the reason I need to do with replacement is because if I don't, the probability changes. So what happens on that second draw would be affected by what happens on the first draw. So again, if I put the deck card back in, so if I replace the card back into the deck, the probability does not change. Okay, so that's what I'm kind of talking about here. Are the 2 draws independent? Yes, they are, as long as I do it with replacement. If I do not have replacement, then things change a little bit. And we will look at that in the next section. So if I do 2 cards from a deck and I'm putting the card back into the deck, the probability that I get 2 kings is the probability I got a king on the first draw, which is 4 kings out of my 52 cards. And then the second draw, again, 4 out of that 52. I can reduce this. I'm going to do this the long way first. For those of you that do it the long way, some of you would have done 4 out of 52. That's my 1 out of 13 and 1 out of 13, which gives me 1 out of 269. Not 169, sorry. Oops, my bad. So 1 out of, let's just rewrite this. There we go. All right, if I want to get 2 hearts, again, we are putting the card into the back into the deck, so the probabilities stay the same. So 2 hearts, that means, well, the probability of getting a heart is 13 out of 52, or 1 out of 4. And then again, multiplied by the 13 out of 52, or 1 out of 4. This is 169 out of 2704, or 1 out of 16. A little bit easier if I do my reducing ahead of time. So, all right, one last problem here on this independence idea, or independent idea. If we have an airplane, has 4 safety mechanisms to make sure that the airplane stays in the air. They all work independently from one another. So what happens to one does not affect what happens to the other. And the probability of any one of them failing is 0.17. Okay, so them failing is 0.17. And we want to know what the probability is that the plane will crash. And the only way it will crash is if all 4 fail. Okay. And the only way and since they are independent, that means the first one has to fail, and the second one has to fail, and the third one has to fail, and the fourth one has to fail. Or 0.17 to the fourth, which if I look at my calculator, 0.17, raise it to the fourth, I get 0.00083521. And so if I wanted to find out what's the probability it's not going to crash, well, here's probably it does crash. If it's not going to crash, that would be 1 minus probability it crashes. Because either it crashes or it doesn't. So 1 minus this 0.00083521, which is, I'm going to let my calculator do the work for me just to make sure. 0.9991647.9. And again, we could round to whatever decimal we wanted and go from there. Okay, I'm going to stop sharing here because this does kind of end section 5.3. 5.3 is a little bit shorter, a little less material, but try not to get these topics, which are a little bit more complex, confused with some of the easier pieces. We don't want to kind of start doing this multiplication idea every time we hear the word and, or if we see the word or, you'll notice we will start to talk about adding. So, but we'll see that later in the more complicated ideas. If things are simple, don't try to overcomplicate stuff. But I will see you guys all in the next video. Have a great day.